Okay, here we go. Good morning, or just, I guess, right at noon. Welcome to the first breakout session of Build 2015. My name is Kevin Miller. I'm a program manager on the hyperscale computing team in Azure, and I'm going to take you on a little bit of a tour of building Internet of Things solutions on Azure, both with technologies that are available today and a little bit of hints of things to come. Mostly, I'm going to demo things that already exist. And I just have to remember which space bar to hit. OK. So evaluations. Kevin is great. All right, good. So let me sort of set this up and give a couple of ground rules. One is that Internet of Things is the most hyped thing. Oh, dear God. Is there a pool for how many times I say the word thing during this talk? OK, good. So it's the most hyped thing I've worked on in a long time in the industry. I mean, I was here for the original browser wars. I have been through a lot of like, oh my God, this is going to change everything moments. And this one's a doozy. But there is there. But there is also this problem where, you know, weird stuff is happening. Old things are getting new names. Batch is now called Cold Path Analytics, and it's cool again. Anybody who knows a little Excel may have data scientist on their business card now. There's just, you know, there's crazy talk. I had a vendor visit me like 2 weeks ago, and he told me that his solution had infinite scale and perfect security. And he did not laugh after he said that, right? So there are some special people out there right now. But like I said, there is some there, and I'm going to try to talk a little bit about the path of righteousness, if you will, in this crazy world. Because you can make a big difference if you think about things a little differently than you did before, and if you saddle up. Anybody who tells you that like security is perfect and easy in IoT is a charlatan, right? Security is not something you can give to somebody else. Security is everybody's problem. It's the cloud provider's problem. It's your problem. It is everybody you hire's problem. It's everybody who works for you's problem. And we have learned this the hard way. I have a big scar on my hand from the security wars at Microsoft. So, you know, you got to saddle up. I'm going to talk patterns and anti-patterns a little bit, things that I've observed from my own experiments and from talking to a lot of customers and partners. I'm going to spend probably a third of the time or so doing a demo. And I'll talk a little bit about how you can get a path to the future from here. So I kind of hinted at this before, but really the first question, when somebody talks about IoT, I tend to hear one of two answers. You know, one of these is like, son, I've been doing that since before you were born. And I am not like 20 either, right? So, and there's some truth to that. Command and control has a lot to do with IoT. There's a lot of overlap there. And people have been doing command and control for 50 years. And then, so, you know, there's some truth to that view. And then there's the other view, which is, oh my God! You know, it's going to change everything. And there's a little truth to that one, too. I warned the sound guy. I was really loud. Now he's really glad I warned him. Like I said, the truth is in between. Both of these things do have some truth to them, because with the continuation of Moore's law, with ubiquitous, pretty close to ubiquitous connectivity and really low price on communications, you really can do stuff that you couldn't do before. And kind of the way that I think about this myself, and I think about where the industry is today, is that there are sort of two extremes where IoT is pretty mature and works fine now. One extreme is where the thing is super complicated, super expensive, or the cost of that thing failure is completely unacceptable. Like you can't even go there to think about what it would cost if that thing failed. So in that case, you know, you can load some expense into the system. You can build a one-off software solution, and it's okay. You can put a lot of expensive sensors and expensive communication devices in place, and it's okay. And that's really kind of where the command and control world came from. And at the other extreme is where the thing is really simple. You know, the canonical example is a thermostat. So it can really only do three things. It can tell you what the temperature is. It can tell you what the temperature is supposed to be. And you can set the temperature. So really, the analysis for this is not what you call super complex. If you have thermostats in refrigerators, and 1,000 of them, and 998 of them say it's 34 degrees, and the other one says it's 72, it does not take an analytical engine to figure out which refrigerator might be broken. And so you can do those simple scenarios because, for one, the analysis is not that hard, and secondly, if you have a lot of them, you can amortize your software cost over a lot of units, and so therefore you can keep the cost down. And I would argue that the middle is the challenge for IoT. Like, if it's real simple, fine, do it now. If it's a rocket, fine, do it now. If you want to do something in the middle, it's really hard now. And I think the challenge for the industry, and really this is kind of the historic Microsoft playbook, is that we want to move towards the middle from both of those extremes. We want to make it easier for some smart person who's trying to figure this out in a garage to do more easily. And at the same time, we want to make it so that the complex solution is not crazy complex and is affordable if you're not talking about millions of, multi-million-dollar devices. So the kind of building blocks of this are really the services that, the Azure services. And really, at some level, I don't care whose software you're running, as long as it interacts with my software. But you have these sort of segments that you're looking at. How do I think about the data on the device? How do I think about connecting the device to the cloud? How do I store data that I care about? How do I do analysis, either batchy analysis where I have plenty of time. I'm trying to figure out how to design the next generation product, and I want to look and see how the current one did. Or more real-time thing, I want to turn the sprinklers on if there's a fire. But you have these hot path and cold path analytics activities, and then you want to do something with that data. You want to create a worker, you want to visualize the data, you want to send alerts, you want to send messages. There's a lot going on there, and one of the things that we announced Convergence last month was this IoT suite, and really the goal of that is to try to make it much, much easier to deploy, manage, operate IoT solutions that span a bunch of different IoT services. So this kind of brings me to my first pattern/anti-pattern for the talk, which is based on a lot of IoT solutions that I've seen, good ones and bad ones. It's really important to think big from the beginning, but start small. And pretty much everything that you do, you want to be able to learn from it. You want to see it evolve. You're going to find in the course of building these solutions that what you thought was the case is probably not the case. You're going to take these steps through, and you're going to go, oh, that's not the data that was actually helpful. Oh, I have the wrong sensor. I'm gathering a bunch of data, and all I'm doing with it is, storing it forever. And we appreciate the money, but really, that's not what your business should be doing. And so, if you think about these things, prototyping is your friend. The proofs of concept are your friend. It is way easier to adjust, which you will almost certainly have to, if you start small. Now, while starting small, it's really important to think about the fact that you do want to get big, and it's a lot, and you don't want to, as you grow from prototype, to have a life event, right? You don't want to go, oh, it worked great at 100. Now I want to do 1,000,000. So I have to throw out everything that I thought about on the 100. So you have to kind of balance these two slightly conflicting priorities where you're saying, okay, I'm going to do a prototype, I'm going to do a few devices, I'm going to try to figure out what sensors I really need before I deploy them. I'm going to try to figure out how to manage them, how to manage identity, how to manage the device, how to update the device, how to secure the device. But think about all that stuff early when it's easy to come back from a mistake, and it's cheap, much, much cheaper. And of course, the anti-pattern here is, let's ship a whole bunch of them and then figure out how to manage them, or how to deploy them, or how to secure them. We've had some really unhappy customers who've gone out and who've come to visit us and say, hey, we built this thing and we deployed 1 million things, and then how do we update the firmware on them? It's like, oh, well, the first thing you have to do is build a time machine and go back to before you truck them all out there and think about management. And really, that's not what the customer wants to hear, right? But that is sort of the way reality works here. And so think about security management. Think about scale. Like if you know eventually you're going to have a lot of data, you want something that can really ingest a lot of data. There's a lot of work with event hubs today, which is really pretty compelling because the amount of data that those things can snort up, I think is the technical phrase, is pretty amazing. And so in this context of thinking about the architecture for the solution, thinking both big and small, I want to take a little detour and talk about the thing itself. And one of the challenges that the industry faces, really, is that the things are so heterogeneous. A temperature sensor is an incredibly simple thing, but pretty quickly the things get complicated and powerful. I have a little BeagleBone thing that I'm using in part of my demo, and it's kind of astonishing how powerful that little dude is, right? And that's cheap. And there's a lot of stuff smaller, and a lot of stuff bigger. And then once you get to large things, then you start getting into logical collections of things that you want to manage as a single entity sometimes. So, a truck on the highway is a complex thing, but a truck in the context of a fleet management solution requires you to think about these objects very differently. On the far right there, the graphic is intended to suggest a smart city, which is obviously an extremely heterogeneous collection of stuff. And some of that stuff gets buried under concrete for 50 years. And so how you think about, again, management and deployment and security, update, frankly, warranty periods. It's just different. And so as we've been developing the architecture for what we're doing, we have to think about extreme hardware and software heterogeneity, right? So Linux, real-time operating systems, things that don't really have an operating system, very complicated collections of objects. Conference room is an object, a corporate campus is an object, a building is an object, a city. And so the architectural requirements that drive for us are things like, okay, we have to make sure that we scale, and we are secure by default, and we can provide latency guarantees when those are required. I'm going to talk about security some more. I won't really talk about defense in depth here, but I'll talk about it a little bit more, and then I'll point you to a talk by Clemens back in this room in a couple of hours that's going to go far deeper on security. And all the time that we're doing that stuff, we have to do what I was sort of hinting at earlier, is that we have to make it much, much easier to get going, to go from zero to I have a deployment, I have a prototype, I have a proof of concept, and then I can go relatively smoothly from proof of concept to final release without having a life event. So the second sort of pattern I wanted to talk about here a little bit is telemetry first. And this is a really important one, I think, because most of, if not all of the successful IoT solutions I've seen have started with telemetry and then moved from telemetry to command and control. And there's a couple of good reasons for doing telemetry first. One is that you just don't know, really, unless you're really, really the wizard. And if you are, we have jobs. But unless you're really, really the wizard, you're going to find stuff that you did not expect in the course of doing this. Like one of the promises of machine learning and something that it actually delivers is that the machine learning finds patterns that the people didn't see. And so if you don't do telemetry first and get the data in and grind it and see what you have, it's really hard to know what you need, what you can do, what your options are. So telemetry first is a big deal. The other reason telemetry is first is it's a lot nicer to do security and privacy work under telemetry scenarios than it is to find out those the hard way when you're doing command and control. So if I'm in a connected vehicle and there's a hack in the thing, but it's telemetry only, then okay, yeah, somebody could find out my GPS location, and I don't love that idea. I actually don't care, but a public figure would really care, right? Maybe you could infer some information about the vehicle and get an IP advantage if you were a competitor from that. But really, in the grand scheme of things, that's not all that scary. By comparison to command and control, where there's somebody in the vehicle and like you turn it off when it's on the freeway. And so, factory automation is similar, right? Worst case scenario, if I have a telemetry breach, well, maybe somebody can figure out how many doodads my robots built last month, and that's bad. But I can take an action back on the device and actually cause it to fail a lot worse, right? And so again, it's a lot easier to work your way through security and privacy implications for what you're doing if you do it based on telemetry. And the other thing that I think I would add about telemetry in general is that you also have to think about the data, not just the data that you're trying to measure with the device, but the data of the device. Like, how do you think about device telemetry that's telling you something about the environment the device is in versus telemetry that tells you how the device is doing? You know, am I in trouble? Do I need help? So the telemetry first pattern is another one that I think is really important. So if I move on and think a little bit about telemetry specifically, and while I do that, I'm going to make sure my laptop hasn't gone to sleep since I'm going to try to use it in just a second. The demo gods and I are collaborating well so far today, and I don't want to screw that up. All right, so the telemetry scenario then is kind of going back to that think big but start small, think about telemetry first. A good telemetry pattern that we see a lot is use event hubs for data ingress, because the ability, what was the phrase I used there, Dan? Snort that data up? Really high scale, easily configurable. Then go into something like Stream Analytics. You could use Storm. For my demo today, I'm using Stream Analytics. And then use Stream Analytics to do some analysis on the fly in real time and to also split the data off so that it goes somewhere else for longer term storage or later analysis with something like ML. And this is a pretty common telemetry pattern that we've seen a lot of times. I want to do some data ingress. I want to do a little bit of real-time-ish processing on it, make some decisions quickly, and then I want to put the data somewhere cheap so that I can come back to it later and do machine learning on it. So these two components, and there's a lot of content in this conference about these two components, so I'm going to kind of go over this lightly here. So for event hubs, really, you just have to think about how quickly the pipe can get your data from point A to point B. To provide security, configurability, high volume, low latency data transfer. And since event hubs support AMQP and HTTP, there's a lot of publishers that you sort of get free on the way in. And the scale here is pretty astonishing. You know, it's at this point we're measuring data in trillions of messages, not millions or billions. And so that's a really powerful thing. And then moving from there into Stream Analytics for processing the data. And I'll come back a little bit to fast path connections after the demo, but really you're talking about two systems that are designed for extremely high data throughput. And so you have the ability to quickly get input and analysis of the data. And with Stream Analytics, you get this extension that you can use a SQL-like language. It's really SQL plus just a couple of 3 commands but it allows you to make some time-based decisions, and it really provides a lot of power. So then for my demo, I decided that I would do the demo as if I was some random dude somewhere, and my boss said, hey, check out this stuff. So I wrote a little website that generates sample data according to a probability distribution. I send that to Event Hubs. From Event Hubs, I go out to Stream Analytics. At Stream Analytics, I split the stream. I push everything to Blob for later looking around. And then I have an action path, which I've done with SQL here just because it's easy to demo, easy to look at along the way. But really, if I was building this solution in the real world, it would be a messaging system that I would go to. And then because I'm going to SQL, I have a worker role here that's Node that's going to take the data from SQL and send it back to my website so I can display it. So yay. All right, so I have a little website here. Lets you pick a probability distribution, a number of seconds to run, and a mean value. So I'm going to do the kind of this backwards chi-squared distribution, and I run it. So I go off and I generate a bunch of data, and I have a little Monte Carlo simulation there that's making sure that the data conforms to a pattern. So this is just, I've got some data. Maybe it's pressure data. I don't really care for the purposes of this. And the pattern that I see in the field is I'll see a lot of low values, and that's fine. And then I see, a build up to some relatively, so the mean here is about 100, and then a relatively sharp tail off on the right side. So you have the data, and if the data is within this sort of normal distribution, that's what you expect. OK, so I'm going to flip back here really quickly. So in my JavaScript, I basically create a little JSON package, the reading, which is a floating point number, and a device ID. And that's all that I do there. So in my website, I have the little thing that checks to see if something fits under the curve of this chi-square distribution, which I can tell you I had not done for a long, long, long time. And then I want to send that data to the client. And now, in the interest of airing dirty laundry, at this point, I do not have a JavaScript SDK for Event Hubs. We're going to get one. We're going to let you do this in any language that you want. But for the purposes of this demo, I used one that was written by one of our MVPs, a guy named Demir, who wrote a little JavaScript SDK and made me real happy when I found it. And also gave me something to give people on my team grief about not having, which was a double, sort of. And so all this little JavaScript extension lets you do is you can create a client and point at an Event Hub instance, then create the message and send the message. Let me switch back here. So I go to the management console. And I have a service bus namespace. Sure I do. How did I do that? And I've created this Event Hub in the past already, but creating the Event Hub turns out super easy. If you have a service bus namespace, you just go create Event Hub. And I did the quick create for this demo, where all I had to do was specify a name for the Event Hub and a region. And the service bus namespace, obviously. So I create that. Then inside the Event Hub, I can configure it. And again, I just took the default. So I have a one-day retention. And here was the important part for my demo. I created a shared access policy that would allow me to send data to it. And so I have a send telemetry, SAS, and a key. And so then when I went into my JavaScript, which is just easier to see here, that where it says SAS key snipped, that was the SAS key name was send telemetry from the site, and then the SAS key there sets a timeout. Then all I do to actually send the data is the message, new event data just JSONifies it. And then the send message sends it and lets me handle any errors. So just a few lines of JavaScript, and data is flowing back up to the Event Hub. So now I need a stream analytics job. Which I really should have started a minute ago. OK, so my stream analytics job then, similarly to create one of these, in data services, stream analytics, quick create, I give it a job name, a region, and I have to have a storage account in that region for monitoring. But again, the quick create created this stream analytics job. Then I had to create an input and an output that I want that data to go to. So the input is the Event Hub. And this was one of the nicest experiences I had in the whole thing, where I just said, point at the Event Hub, test connection, and it said, OK, I'll connect it, all done. Then an output. In this particular case, the first one I'm doing is the output to blob storage. And so I created a friendly name for the blob storage, pointed at a storage account, gave it the key, and a container inside that blob storage. And so now the only thing left to do is to create the query. So I could have just said select star, route from Event Hub to blob storage, and be done in just like 25 characters, which shows you how quickly you can actually get legitimate things going on here. But I wanted to show, I expanded the star here because I wanted to show that in addition to those two data fields that came in from my JavaScript, Event Hub has tagged the data as it has gone through with an event processing time. And so I have the device ID, the reading, and now this additional field, event processed UTC time. So now this goes out to my blob, and the in and the out here are just the friendly names that I created when I configured my inputs and outputs. So now if I go back here and run this thing again, then data will start flowing through. So I can go to the Azure Storage Explorer. I'll give it a second here, just not to press my luck too far. Good. And then I'll do a refresh. Make sure I'm looking at the most recent one. There it is. And so now my data is flowing through, and I see that I have this series of device ID, reading, and date time. And so now my path to where I can start doing machine learning on this data is complete, and I've written a few lines of JavaScript and one SQL-like query. But let me show you something that's a little more, that shows a little bit more of the power of stream analytics here. And actually, let me show you over here so it's easier to see. So now I have a query where I say, OK, based on my personal observations of working with these thingies, or based on machine learning, I now have found a pattern that I want to take an action on in relatively real time. Right? So I go, OK, in this probability distribution I was talking about, let's say that's a pressure gate. And I know that if the pressure goes up over 115 twice within a 15-second period, then I probably ought to think about doing something. And again, this is just a made-up example, but I think it is a pretty reflective of a lot of real-world scenarios that we've been talking about with our customers and partners. So the differences here from sort of standard SQL are there's really just a couple things. One is you see in the from field that I'm specifying which field I want to use as the critical time in my calculations. And then at the top, the select statement is just, I'm going to timestamp these so later when I'm looking back at them, I can go, OK, that was when I found this anomaly. I'm taking the device ID and the count, and then the count refers to the number of times that I find this value over 115 in a sliding window of 15 seconds. And that sliding window is clearly one of the other major additions from Stream Analytics. And it's really kind of astonishing, because I was trying to think how I would do this without something like this. And all solutions involved me writing a lot of code and swearing and a lot of old ancient languages I don't even know, right? Because this is just not trivial to do in like regular SQL or in a programming language. And there's 3 different types of these sliding windows. There's one sliding window which just says, I want non-overlapping windows of a certain length. There's another one that says I want overlapping ones. And then I picked what is the most finest grained version of that, which is a continually sliding a window, where the window slides on every incoming event. And so you can actually see anything that happens in any arbitrary sliding 15-second window. And the work that the team did to make that possible is pretty cool. All right, and then just for completion, so you can see how the rest of the demo works, then there's another select statement in here too. I have 2 select statements in one job, which probably makes sense sometimes and doesn't make sense other times. And the Stream Analytics guys will probably be talking a lot more about that in talks that they have coming up. But in this particular case, I just also blasting all the data into a different SQL table. So I can see, so later on I can do a query that says, OK, if I get an alert about this device, now I want to go back and call out the SQL and get all the data that that device has sent in over this recent time period. So if I go to SQL, I have these 2 tables. Alerts, which is just all the data, and alert counts, which is the number of times that I find the bad reading during the time period. So let me delete that one. OK, now it's clean. All right, so now if I go back and run this sucker again, I should see the 2 Stream Analytics jobs running. One that's just pushing everything to blob, so I can do ML on it later. The other one that's doing the analysis, finding me the misbehaving devices so I can do something with them. So now if I go back and refresh that query, then I see that I have this incoming stream of devices, and I see that device 94 and 62 and 69 each had 2 bad readings within a 15-second window. So now all that's required for me to do to sort of complete the loop back on my, my demo is to connect then that SQL data back to the website so I can report it here. So if I go back here, now I have a call from my website that just goes get Stream Analytics results just as a post, sends with it a start date time so I can see which results I want to look at. And then in my node job, I have that post defined. I use the SQL node extension so I can create a SQL request, the connection and request, and then just do my query, which basically says I want anything that's on this date time later than the time that I've been passed in. So, whoops, noder. I wonder what noder is. So now I start the node job. So now I go back and run this again. And unless the demo gods get me on random numbers right now, after a few seconds, I'll start seeing the data that comes in, and I'll start seeing a table here at the bottom that has machines that have been identified as being outside that range. Hey, I paid my demo god dues this month. Yay! All right, so now I've sort of completed that loop. And the thing that I think is important here is, I'll go back here, that that was really not very much code. There was a few lines of JavaScript to get the thing in. I did, get in little, I used to be a developer mode and screw around with the website a lot and do like Monte Carlo simulation and stuff like that. But really, the functional parts of this code were, a few lines of JavaScript to push data up, a few lines of an extended SQL syntax to run time-based queries, and then a worker role that basically completed the loop. And so if you were doing this in a real-world deployment, it would be messaging out the back end. But that sort of model holds up. And we see this one over and over and over with customers that are doing IoT for the first time. The first step is like they get some telemetry in and they want to take some action based on the telemetry. They have some machine that occasionally does something, and when it does something, something needs to happen. It's something that collects samples and it's full and it needs to be picked up. I need an industrial strength mole killer in my backyard, and if they had one, then when the mole killer would call the guy to come and get it before my dog digs it up. Right? There's a lot of scenarios. Some of them silly, but a ton of scenarios go back to the same pattern. When I see some data, I want to take some action. If anybody here staying at the Marriott Marquis? Few? Okay. Elevators. One of the elevators is out in the tower that I'm in this morning. And there's a dude there fixing the elevator and making a lot of noise, but fixing the elevator, which is great. Maybe with some telemetry, he could have been fixing that elevator at 2 o'clock in the morning instead of at about 8:30 this morning when everybody was trying to get out of that hotel and come here. And again, it's a simple scenario. You get some telemetry, you realize something needs to happen, and you roll a truck in this particular case because some dude had to come fix the elevator. But probably they didn't know until somebody noticed that the elevators were slow this morning and called them. So it's a great, these scenarios are really kind of everywhere. Easy to get started. And again, it kind of follows that pattern that I was talking about earlier about do telemetry first, start small, start with virtualized devices. That's one of the things that we're shipping is the ability to create a lot of virtual devices and hit systems at scale. So this brings me to another pattern that I almost learned the hard way of building this demo, which is don't stick your head in the fire hose unless you know what you're doing. And that's because it's tempting to go, oh, you know what? I need to massage this data. So I want to put a little worker in here to massage the data. Well, don't do that between two high bandwidth components unless you really know what you're doing. Event hubs can push a humongous amount of data. Stream analytics can input a humongous amount of data. It's way smarter in general, unless you're really the wizard on this stuff, if you have to do any processing of that data, do it before it gets in the fat pipe or after it comes out of the fat pipe, not in the middle. I mean, I had the polite version of this, and my dev counterpart said, don't stick your head in the fire hose. And I thought, OK, that's more memorable. I'll have to give him that one. Although I really do hate to give him anything. So let me look here and make sure that I'm sort of kind of on the right path. OK, good. So then the fourth pattern then is about defense in depth. And like I said before, Clemens has a talk in here at 2 o'clock where he's going to talk a lot more about security than I am. But you can't put security in after the fact. It really have to be a cultural thing. And you can't go, oh, the cloud vendor's in charge of security, because that's not going to work either. If you're going to get into this business, you have to be willing to think about your business differently. You have to think about things that maybe you really never had to think about before. So, because you might, by putting something on the internet, become an interesting hack target when you haven't been before. There's been a lot of stuff in the news recently about connected car hacks and connected car possible hacks. Well, 5 years ago, if you wanted to hack a car, you had to have physical access to the car. And you might get beat up. And if you succeeded in hacking it, you got one, which is not really a very interesting target. I'm risking my physical security to hack one car. Not really very interesting. If I can sit thousands of miles away and potentially hack a lot of them, OK, that's interesting. I mean, to a bad guy. Not to me, I hope. just since this is being recorded, I don't want to get in too much trouble. And the other thing that comes up in thinking about defense in depth is you have to think early and often about it. So, one of my favorite examples is if you have a thing and it's got an app. So now my thing is controllable by my phone. Okay, that's great. What if I sell the thing? God forbid it's a big thing like a car, and I have like an unlock and start the car app on my phone, and it is a nice secure connection to that car, and now I sell the car, and then now, I walk by it and start it up. It's almost a trivial thing, because you really wouldn't think about it necessarily in the course of building the car, but that was a scenario, or building the thing, whatever your connected thing is, right? So this kind of highlights the fact that you have to think about this throughout the entire process. And the people like us who have been doing stuff out in the open on the internet for a long time have all learned this the hard way. That security has to be a lifelong practice, and you have to think about it from the very beginning. You have to think about, how do I think about the commands? Like, how does the thing think about the commands? Here's an example that's completely outside the IoT, like banking. I am not willing to have a lot of hurdles between me and checking my balance. I don't want like 7-factor authentication to check my balance, because that would just irritate me to death. But if my bank actually sent me a message to my phone and said, did you just try to wire $10,000 to, Elbonia, right? I'm willing to type in the 6 digits to say yes or not or no. And you have to think about security of things in the same way. Like suddenly if the thing is getting commands like it's never gotten before, should it call home and go, hey, Mom, is this still you? Because you've never asked me to set myself on fire before. And that has to go in at the design level. Like, I don't want my connected robot surgeon to say it's OK to do a firmware update while it's got my spleen in its tentacles, right? I want it to have a local state machine that says, I'm not listening now. And you have to think about that when you're designing the thing, not after you've deployed a bunch of them and it's got my spleen in its hand. OK. I'm mostly preaching to the choir on this one, but I'll preach just one more moment, because the security guys are going to kill me if I don't. You also have to think about the stack, from the physical security of the device all the way up to the application level, to the policies that you put around data transport. It's a big deal. So now I'm going to talk a little bit about where we're going now from here. So everything that I built to this point and everything that I talked about to this point is really stuff that exists today. Go out, go and do it. We have customers who are deploying all this stuff. We have infinitely more complicated scenarios than the little thing that I walked you through in real deployment based on our architecture, and that's great. We announced this Convergence last month. There's a recorded talk by Elio DiMaggio on the IoT Hub, which is part of this, that's definitely worth a look. But the way we're trying to think about this, and it kind of goes back to that picture I had at the very beginning of the bell curve, is that we have to make it much, much easier to do solutions in the middle, solutions of things that are more complicated than toys, and things that aren't so expensive that it's OK to spend hundreds of thousands of dollars in software and monitoring per device, right? 90-some% of the world is in between those two things, I think, right? So the suite really is our effort to make these things a lot easier, to make it much quicker to go from nothing to a working deployment, and then easily move from there to real proof of concepts, field deployments, and production. And to do that in a much more predictable and understandable fashion than is currently the case. Like you can see even in the case of the little demo that I did, that I kind of picked and chose some blocks from that original Azure IoT Services chart and put them together. And so what we want to do is say, OK, you're going to pick a scenario, and we're going to instantiate an instance of a complete solution based on that scenario. And then you can go customize it to your heart's content. We might, by default, put stream analytics in. You might want to replace that with HD Insight. Great. We might, pick a storage, and you want a storage system, and you would prefer to do another one. But the idea is that we'll very quickly and easily get you going with real scenarios. And the first three are the ones on this slide, remote monitoring, asset management, and predictive maintenance. But like I said, a lot of these scenarios are really similar once you get the outermost UI piece peeled away. And then we're also using the suite to simplify the way you think about how much these things cost. Because it's, for those of you who have built complicated solutions on Azure now, month-to-month billing is kind of a mysterious act. There's a lot of tickers running, and I may have to expense my Azure bill this month for the first time because I ran a lot of stuff, and I have no idea how much it's going to cost me. And it's coming right out of my checking account, so hopefully I didn't go crazy and leave that thing running for like 7 days in a row. But we want to make the ability to budget for it much more predictable across Azure. And then going back to that start small but think big, we want to make sure that everything that we provide in the solution has really high scale. Not infinite scale and perfect security like the crazy guy offered me a couple weeks ago, but that we want to make sure we're staying ahead of anybody's requirements to push the technologies. Part of the way we're doing this is that we kind of think about a reference architecture for how you build Internet of Things solutions on Azure. And it starts with getting device information in, transports, a gateway that manages inbound activity, or in the case of the IoT suite, also command and control. And then within that gives you the ability to use all of the power that's provided by Azure. And then also allow you to think rationally about the way you present data at the end. So, the thing that I built fits in this architecture. I used event hubs for the cloud gateway. I used stream analytics for the event data processor. I had a couple of different kinds of storage there. The control system worker role was my little node.js job. And then in my particular case, I was not sending a command and control back, but that's a relatively straightforward thing to do with this architecture as well. And that kind of brings me to my final pattern, anti-pattern, which is if you think about that reference architecture, and we're going to be publishing a lot more detail in the reference architecture, but if you think about that reference architecture and build to it, then basically your experience becomes as more functionality shows up in the suite, things just get easier. So you can do stuff now, but there is going to be, in some cases, there is going to be more work to do. Like if you try to do command and control and you use event hubs, then that's really an ingress method. So you have to figure out how to do the commanding. And you can do that, and we have customers doing it today with queues and topics and things like that to send information out. But one of the things that comes in the reference architecture as a part of the IoT suite is an IoT hub, which basically extends the capabilities of event hubs to also allow device identity, device management, security, and command and control. And so then the scenario becomes, okay, now I just have to send, rather than having a queue or a topic or something like the messaging system that's routing things back out to my device, now I can send the message back to the gateway, and the gateway will then do that for me. And the other big piece that has not released yet, but it was coming out very soon. Dan down here would probably say it's coming out as soon as Kevin says it's okay, because Kevin is the guy's blocking it right now, is these libraries for devices. And this is a very portable C99 library that runs on just about anything. We have it running on things as small as thermostats. And it allows you to quickly describe to the gateway the capabilities of your device. So you basically say, here's the stuff I know how to do, Mom. And then now the gateway knows what sorts of data you can provide and what sort of actions you can take based going in the other direction. So really, those are two big pieces of this. And if you build toward the reference architecture, then you just sort of get some of this additional functionality more or less for free once those pieces come online. I think I'm going to press my luck just a little bit and do a second demo. Whoa. Assuming I can type my password. OK. So this is the event. Uh-oh. This may be where the demo gods get me. Oh, what do you know? OK, so this is one example of the Event Hub library, of the client library. This is the Event Hub version, so it's quite simple because it's really not doing anything fancy with the data on the way in. And what it allows you to do then is, like I said, this is C99. So I have it running on a BeagleBone up here. And you say, OK, I have a connection string, which is the same connection string that I used with my JavaScript code to send data up, and an Event Hub path within that. Then the library lets me quickly create a data handle. And in that particular case, I'm sticking that same content in here that I was using in the other demo. It's a floating point, a reading, and an integer that's the device ID. And then I have a little error handling there because it's C. And then I create a client handle. I should probably actually have this so you can see the full screen. There we go. And then I send the message. And there's a send single, which is what I use here, or there's a send batch where you can send an array of items. And then, it being C, I have to clean up after myself at the bottom. But if I go back here really one more time, I have a BeagleBone here. I have that. So it's here. It's generating device IDs and readings, pushing them up. So if I go run this thing again, this is definitely reading high, which, unless I stopped my stream, there we go. So, and I had the BeagleBone pick a device ID over 500 because I knew I didn't have any of my virtual devices there, just so it would quickly pop up on the screen. And so adding the client then to that path was pretty much trivial. And then the other piece of this, and I'm gonna skip on this because I'm about out of time. I'm gonna take a couple questions. Is you can then use Power BI to do the visualization instead of my website. So really, I could do my little scenario where I have my, the library running on the device, sending up to Event Hubs, through Stream Analytics, to Power BI, and not really have to write practically any code at all to actually see the scenario in action from end to end. So the summary then, I guess, is these 5 patterns, anti-patterns that I talked about along the way. That you really need to think big about the architecture components you use, but start with small prototypes and proofs of concept. And you're just far more likely to have a good experience if you do it that way. Telemetry first, I'm a really big believer in that, partially, as I said before, because you just don't know what you have until you see what you have. And then you can make better decisions about it. Don't stick your head in the fire hose. Good advice in life and in IoT. Then, security thing really has to be a focus from the very beginning. You just cannot put that off until the end. And finally, building to the reference architecture to make it easier to move to the suite as those components become available. This is the only slide that somehow or other got here that I did not write. I had a couple other things on here. So there's a talk at 2 in here with Clemens going to talk about security. Sam and Steve Teixeira are doing an IoT overview, which probably would have gone in this slot, but Sam's too smart to take the slot right after the keynote. and that's at 5 in 1A. Then there are 2 of these on-demand sessions, one by Dan on Event Hubs, one by Elio on the IoT suite, and specifically the IoT hub within the suite. Those are definitely good watches. And then the other thing that I had on here, there's a talk by the Stream Analytics team, an overview of Stream Analytics and ML and other analysis services that I think is really good. And then finally, the thing that really, I'm really sorry isn't not in here, there's a case study about Itron's experiences in trying to do security-based programming, security-based product development. And if you search for Itron on Microsoft site, you'll find it. But it's how they tried to do sort of the trustworthy computing basis that Microsoft uses, security-focused development, and how they tried to transform that to their business and their experiences doing that. And that's really a good read. And I believe that's it. And I've got maybe 4 minutes or so for a couple of questions if anybody has any. Otherwise, I will hang out for a little bit afterwards and be happy to chat. Thank you very much.